What's up, classmates? Do you know how to transform this sentence into this equation? Now, if you don't, stay tuned and continue to watch this video for you to be able to transform this sentence into this equation. But before that, don't forget to click the subscribe and hit the bell button for you to be updated on our lesson in mathematics. So let's get started. So now let us discuss the inverse variation. So I have here a picture of kids playing on the seesaw, and I have here two persons going on different direction. Now these two pictures, I will relate it in our lesson as we discuss the inverse variation. So our objective will be the following. First, we are going to write our formula. Second, we are going to solve problems involving inverse variation. And third is we are going to apply inverse variation in our real life situation. So now let us discuss inverse variation problem. But first, let us define what is inverse variation. So by definition, it is as one variable increases, the other variable decreases, or vice versa. So as you can see on our first slide, we have two pictures. The first one are the kids playing on the seesaw. So as you can see, if you are on the seesaw, as one kid goes down, the other kid will goes up. Or if the kid will go down, the other kid will go up. On the second picture, you have two persons walking on opposite direction. So as you can see, as the lady going to our direction, the man goes on to the other direction. So that is what we call an inverse variation. And there are clues to remember on how to identify an inverse variation. So if we have a sentence, y varies inversely as x, and there exists a real number k, where our k is our constant of variation, or y is inversely proportional to x, if we are going to write the formula, it is simply as y equal to k over x, where our k again is our constant of variation. So if we are going now to find our constant of variation, this formula y equal to k over x, we can just rewrite it as k over x equal to y. After that, we are going to multiply all sides by x so that we can eliminate the x in our denominator and our numerator. So what will remain is the letter k. So our constant formula for inverse variation will be k equal to y times x. Then again, where k is our constant of variation. So let us now have an example. So we are going first to write the formula of the following. So let's have number 1. If x varies inversely as y. So if you remember on the previous slide, if we have this statement, we can simply write it as x equal to k over y. Next, if r varies inversely as the squared of s. So as you notice, there is the word squared here. So our formula will be r equal to k over s, then squared, since it is stated squared of s. Then lastly, if a varies inversely as the square root of b, so we will have a equal to k over the square root of b. Now since we are already done with writing the formula, we can now try to solve our problem involving inverse variation. So let's have our first example. So if y varies inversely as x, when y is equal to 3 and x is equal to 7, then we are going to find y when x is equal to 9. We are going to write first our formula or our equation. Take note, we have the word y varies inversely as x. So therefore, our formula will be y equal to k over x. Then the second one is we are going to substitute the values. So what values are we going to use? So the values that we are going to use will be y is equal to 3 and x is equal to 7 for us to find our constant of variation. So that will become 3 for y and 7 for our x. Then we are going to put 1 on our denominator in 3 so that we can easily apply the cross multiplication so that we can have a fraction here and a fraction on the opposite side. So if you are going to multiply 1 times k, so the answer is just k. And if you are going to multiply 7 by 3, the answer is 21. And this is now our constant of variation. Now, the second problem is we are asked what is our y when x is equal to 9. So, substituting our equation by y is equal to 21 over x. So, our k here from the equation will be replaced now by 21. And since we have already x is equal to 9, our x here will become 9 also. Now, since 21 over 9, if you are going to divide it, it will not give us a whole number. So we are going first to find its lowest term. So the lowest term will be 7 over 3. Or if you are going to write that in decimal, that is 2.33. Next example will be word problems. So we will have in a house, the number of person is inversely proportional to the number of minutes, the time they can finish cleaning the room. Now, given that 3 persons can clean the room in 15 minutes, how many minutes if 5 persons will clean the house? So on this problem, first, we are going to identify what is the formula that we are going to use. Now, take note, there is the word inversely proportional. So, therefore, this is an inverse variation. But, we don't know what is the letters or what are the letters that we are going to use. If this is the case, we can simply assign a letter for our problem. And take note, the important words here is this. The number of person or person is inversely proportional to minutes. So we can let our P will be the number of person and T will be our time, that is in minutes. The next one is we are going to write our equation. Take note, it is inversely proportional. Therefore, P equal to K over T. Then next, we are going to find what is our constant. So we are going to multiply our P by to T. So we will have K is equal to PT. So we are given now 3 person and 15 minutes. So therefore our P is 3 and our time is 15. Then the next one is we are going to find how many minutes if there will be 5 person that will now clean the room. So we will have P is equals to 5 and T is equal to unknown. Therefore our solution now, so from K is equals to PT, so we'll have 3 for our person and 15 for our time. So our K now is 45. So going back to our formula, so P is equal to 45 over T. So we are just going to replace our K by 45. And therefore, our P, substitute it with 5, and T is our missing because we don't know how long they can finish it. Now, why is it that our answer is 9 minutes? You are just going to interchange the 5 and the number T. So your 5 here will replace your T, and your T will be put to 5. So that will just become 45 divided by 5. And that is 9, or 9 minutes. Now, since we already know how to write our formula for inverse variation, and we already know how to solve problems involving inverse variation, we will have now an exercises so that you will be able to practice if you understood this lesson. So first, we are going to identify the correct letter of the following question. That is for number 1 and for number 2. That is 1 point each. And the number 3 to number 5, you are just going to identify what is the constant of variation. Simply write your answer. Now, for number 6, 7, and 8, you are going to write the formula for the following question. For number 9 and number 10, you are going to write an event where you can apply the inverse variation. And lastly, we will have now our word problem. So you have to hear the word problem and the point system. So this will be 10 points. So all in all, our exercises is equivalent to 20 points.
Thank you for watching this video. Don't forget to click the subscribe and hit the bell button for you to be updated on our next video. Until next time, peace!